Hey everybody, sup. As you can tell, it's not Dr. Levan today. It's Justin, here to bring you a fire trigonometry video for functions. Let's get started then. Today we're going to be doing Trig Identities, which are essentially, we're going to take the trig functions that we've been learning about for the past couple classes and kind of turn them into logic puzzles in a way. We're going to, by the end of this video, be able to take something that looks like this and be able to definitively prove that this is a true statement, that sine y plus tangent y over 1 plus secant y equals sine y. And we'll get to that by the end of the video. Might look a little daunting now, but we're going to learn a couple tips and tricks in order to get through a lot of these here. So let's start with something a little easier, something that we might be able to see pretty quickly here. Let's take sine theta equals cosine theta times tangent theta. Now, the first trick, and I'll be writing these off to the sides here, that we'll want to use when we're doing these things is sometimes it's a lot easier if we take everything into sines and cosines. So I'll write that off to the side so we can remember it for later. So all we want to do here is if we convert everything to sines and cosines, we might see that through some algebra so we can get some things to cancel out here. So we're going to take the sine. We'll just leave it alone for now. So we'll write it underneath. And now let's look at this. We have cosine times tangent, and if we remember, tangent is just sine over cosine. Well, now we have a cosine times a 1 over cosine over here. So those things are going to cancel out. And what we're left with is sine equals sine. And so for a lot of these problems, this is going to be our main approach for solving them. Now, sines and cosines are going to get us pretty far within getting through some of these problems. But what we're going to learn here is something that's very key that's going to show up in a significant number of these problems. And it's called a triangle identity. And we derive it from the unit circle. So let's remember that any spot on the unit circle, any theta value, so we'll take pi over 6 for example to start, we can define its x and its y by the sine, or by the cosine and the sine. So if we took a triangle out of this circle, now we know by the definition of the unit circle that this triangle is going to have a radius of 1 everywhere. So if we extend that out over here, we'll have 1. And we know that our angle measurement over here is pi over 6. And we know that this is some y value and this is some x value. And when we look to find these, we can relate all of them using the Pythagorean theorem. And 1 squared is just 1. And we know from some of the past lessons we've done in the past couple classes that our y value is the same thing as the sine of that angle. And this is the same thing for x as the cosine of that angle. And so what we can do is we can then substitute those in for x and y and get cosine squared of theta plus sine squared theta equals 1. This cosine squared plus sine squared equals 1 identity is going to be very important for us being able to figure things out. And so if we look at this, right now we just kind of have an expression. But the real power comes from if we did something like subtracting sine from both sides. And now we're going to be left with, on the left side, cosine squared of theta. That's going to equal 1 minus sine squared of theta. And now we have an expression that's in terms of just cosine over here on the left. And so when we do some of these problems, whenever you see just a lone cosine squared or a sine squared, we might be able to manipulate parts of our expression, like we did over here and here, in order to just receive the thing alone by itself. And so we'll be using this on this next problem here, where we have sine squared theta minus cosine squared theta equals 1 minus 2 cosine squared theta. And remember, our first step here was sines and cosines. And our second step now is the triangle method, the triangle identity. And if you look, we're already in sines and cosines. So my recommendation would always to be, look what side looks more complicated. And our left side looks a little bit more complicated, right? Because we have the sine squared and the cosine squared. So we're going to want to focus on that for our manipulations and try to get the left side to look like the right side. And so what we'll do is we'll take the right side and we'll just go ahead and rewrite it down because we said we didn't want to touch that. And now on the left, we're going to utilize our triangle identity in order to determine how it looks like the right side. And so if we remember, we said that cosine squared plus sine squared equals 1. So we have cosines on the right side, so we should try to get everything in terms of cosines. So what we'll want to do is we'll want to be able to replace this sign with some expression that's just written in cosines. And when we do that, we should be just left with cosines on the left side. So what we'll do on our triangle statement down here is we're going to subtract cosine from both sides. And this will leave us with sine squared equals 1 minus cosine squared, just like we did on the last slide. Now, we have something that's pretty nice. We have an expression for sine squared that we can now substitute into our original equation. So we're going to take our sine squared on the left, and we're going to plug in 1 minus cosine squared. And that's still subtracting off another cosine squared theta. And now we look and we see that we can do something. We can combine here the cosines. And now we'll have 2 cosine squared theta. And if we look, that's equivalent to the statement that we wanted to get it to equivalent in the first place. And that answers that problem. So let's move to another example where we're going to use both the sine and cosine method and the triangle identity in order to solve our problem. We're going to take 1 minus cosine squared theta and have that equal to sine theta, cosine theta, tangent theta. Now at first glance, both of these sides look decently complex. But what we'll want to do is we're going to want to work with the right side this time. So we're going to keep this side alone. And we'll go ahead and move it down already. And this will be one where we end up working with both sides at some point, so it's very important to keep some consistency and make sure that we're just keeping things in line like we are over here on the left side. So on the right, let's use method 1 first. So let's do sines and cosines. So we have sine, we have cosine, and tangent is sine over cosine. Now we're going to simplify on the right side. We know that our cosines are going to go away. And now we're going to have a sine squared term over here. So now we have 1 minus cosine squared theta equals sine squared theta. And then we're going to use a triangle. And we know from that last slide that sine squared is equal to 1 minus cosine squared. And remember, we found that by doing sine squared plus cosine squared equals 1. Very important, because that's going to get us through all these problems that we're basically doing today. And again, we can now substitute this for that, and we have 1 minus cosine squared theta equals 1 minus cosine squared theta, and we're done. To finish one of these problems, all you have to do is just prove you have some equivalence on both sides. So if you end up with 1 equals 1, that's perfect. If you end up with 2 equals 1, you made a mistake along the way. Now let's look at a problem that's going to use some of our inverse trig functions. Now again, sine plus cosines and our triangle inequality are going to produce most of our results here, and this one's going to be no different. So let's take one that uses secant theta times tangent theta times cosecant theta times cosine theta. We're going to say that all of that is equal to secant theta. Now looking through this one, we have a lot of things on the left side, so we're going to stick with that side. So we're going to take our right side and we're going to put it down again. We'll just rewrite it. And then we're going to convert everything to cosines and sines here. So secant is 1 over cosine. Tangent is sine over cosine. Cosecant is 1 over sine. And cosine is cosine over 1. And let's go ahead and look through what we cancel out. That cosine is going to cancel out that cosine. That sine will cancel out that sine. Left with 1 over cosine equals secant. If we remember, cosine and secant are inverses, so 1 over cosine is the same thing as secant. And so secant equals secant. So for the most part, we're just going to take things sines and cosines in the triangle. And I'm going to keep repeating that because that's basically what we do for every single problem that we're going to get here. So let's move on to a little bit more difficult one. And it's going to utilize a triangle in a way we haven't used it yet. This one we're going to take cosecant squared times tangent squared minus 1 equals tangent squared. Now you might think, because I've said it a bunch, convert straight to sines and cosines. But here, we might have something a little more interesting going on. And if we try to approach it using the sines and cosines method on this one, we would get this. I'm sorry. Switch the order there. But you'll see. We get this, and that really isn't helping us simplify these things. It's getting a lot more difficult because then we would end up with sine to the second over on the top and cosine to the fourth on the bottom. So if it looks like it's getting a little bit more complicated, that's probably not the right way to go. And so for this one, we're going to utilize number 2 again, the triangle. And if you're looking at it, you say, well, how do I do it? You know, sines and cosines is what we had it. But if we think about that statement, sine squared plus cosine squared equals 1, or cosine plus sine, it doesn't matter the order. What happens if we were to divide through by sine? If we took everything and divided it by sine squared, what would happen? Well, now our first term is going to become this. It's just going to become 1. A number by itself divided by that same number is going to be 1, and sine at the end of the day is just a number. So we're going to have 1 for here. We're going to have cosine squared over sine squared, which we know is cotangent squared. And then on the right side, we'll have 1 over sine squared, which is cosecant squared. And if you look at that, we've now created a new identity that's going to be able to help us solve the problem that we're currently working on. And just so we have it in our notes for later, if we were to take the same thing up here and divide through by cosine, we're going to see that we're going to end up with a third identity, and those 3 together make up this triangle identity. So we divide through by cosine, we're going to get for the first term tangent squared. For the second term is where our 1 comes out, and the last one is going to be secant squared. And so this here and this here are our 2 other triangle identities, along with our original identity up here. So make sure we have these written down in our notes because they're very important for solving these. Now let's get back to the problem at hand. We had cosecant squared plus, I'm sorry, not plus, times tangent squared minus 1 equals tangent squared. Make it sure. Okay. So on the last page, we found that we had this here, 1 plus cotangent squared equals cosecant squared. And if we look on the left side, we've got that cosecant, so we're going to use that idea. First, we're going to take our tangent, and we're going to drop it down because we don't want to touch that side. Next, we're going to take our cosecant expression, and we're going to put it in for cosecant. 1 plus cotangent squared times tangent squared minus 1. Now, we're going to do some distribution here. So 1 times tangent squared is tangent squared. And then we're going to get plus cotangent times tangent minus 1 equals tangent squared. And now we need to determine what this piece is going to equal. And if we use our sines and cosines method on this section right here, we have cosine squared over sine squared times sine squared over cosine squared. And if you look at that, everything cancels out, and we know if everything cancels out through multiplication and division that this piece is going to equal 1 right here for us. We'll drop down the rest of the things. 1 minus 1 is 0, so we are left with tangent squared equals tangent squared, and we've solved that trig identity. And before we keep going, I want to point out that I made a mistake on the last slide here. Cosecant is not 1 over cosine, it is 1 over sine. So that problem is actually a lot easier than I made it, but if it shows anything, it's that there's a lot of different ways that you can run through these problems. So definitely try every method that we learn on things. Definitely a reminder that even the great people like Justin can make a mistake, then everyone can make a mistake. So we're about done here with everything that we need to know how to do in these problems. Basically, to get good at these, all you have to do is kind of work through them a lot and just keep trying your best on getting through them all. So we're going to work through one more problem, and then from there we'll go ahead and review all the techniques that we've done, and then you should be good to do all of the classwork that we get when we get back from break. So let's go ahead and do this one final problem here. We have secant theta sine theta over tangent theta plus cotangent theta, and we're going to say that that's going to be equal to sine squared theta. Again, we have our two tools here, sine and cosine, and the triangle. If I could draw like a little toolbox around them, I would, but I have no drawing skills. But I'm sure that that'd be a great thing to do on your notebook or something else. We know secant over here is going to be 1 over cosine. We know sine is just sine over 1. Tangent, sine over cosine. Cotangent, it's going to be cosine over sine. Let me erase that. Cosine over sine. And remember, we're just going to drop sine squared over. So looking at this, we know we can add this bottom part if we find a common denominator. So let's go ahead and do that. This part is missing a sign on the bottom for what we could use for the common denominator. So we're going to multiply this side by sine over sine. And this side's missing a cosine. If we simplify, we get sine squared over sine theta times cosine theta plus cosine squared theta over sine theta times cosine theta. And we now have a common denominator, so we can add. So now our entire expression is 1 over cosine times sine over 1, all being divided by sine squared plus cosine squared over sine times cosine. And now we can use our tool number 2, the triangle. We have sine squared plus cosine squared right here, and we know that that equals 1. So we're going to make that equal 1. And so now our bottom of this is now 1 over sine times cosine. And we'll go ahead and we'll simplify the top now. So we have this. I'll go ahead and rewrite on the next page for a little bit more room. Sine over cosine all over 1 over sine times cosine. And then we said at the very beginning we want that to be equal to sine squared. And now we're going to use algebra to get through the rest of it. So we're dividing by a fraction, so we're going to flip by the reciprocal and multiply. Sine over cosine times sine, and these were squared, I think. Yes, they were. On the top they were not, so we're good. We have the right thing written down. That'll be times sine times cosine over 1, because again, we took the reciprocal, we flipped it, multiplied. And now we see that our cosines are going to cancel out, and we're left with sine times sine, which is sine squared, which is what we were looking for. So let's review all the techniques that we've done today. We have our nice toolbox here that I'm going to draw poorly. There we go. Here's our toolbox that I said I was going to think about drawing. And inside of there we have our two tools. Our first one was sines and cosines. When we're using sines and cosines, we always just are thinking, which side of this, if we put it into sines and cosines, is it going to be most simple? So we're going to change all trig functions into sine or cosine. And that's the gist of it. And from there you can do some algebra like we saw in this last problem and cancel some things out and move some things around. And that's from getting everything in sines and cosines. Number 2 is our triangle identity. Remember from that, we took the cosine squared plus sine squared equals 1. And again, sometimes sine will be written first, sometimes cosine is written first. Either way, you have the same statement. We took that and we turned it into the two other statements, cotangent squared plus 1 equals cosecant squared, and 1 plus tangent squared equals secant squared. And remember, we found those by just taking this and dividing through by either cosine or sine. So if you're on a quiz or a test and you're not given this identity, cosine plus sine is really easy to remember, and sometimes it's a little tough because when you do solve for something like secant, when you do solve out for tangent in this one, you're going to get secant minus 1 equals tangent. And so sometimes it's a little difficult to remember where that minus goes, if it goes with the secant on that secant side or on that tangent side at the beginning. But cosine plus sine is the only one that's going to be the two trig functions added together is going to give you the positive 1. And so this is really easy. If you can remember this one, you can gather all the other ones out just by dividing through by that cosine squared or that sine squared. So just remember everything in our nice toolbox here, and you should be good to go for these problems. And I'm pretty sure Dr. Levan ends it with a little heart, so I'll do the same thing. Just being a copycat. And I hope everyone has a good weekend. Thank you.